Jai Hindi students. Now today we will discuss about the chemistry. This is my YouTube channel Chemistry by Sir Harish. It is also available on the YouTube by the name Kanha Tutorials. Okay. Now today our topic will be temperature volume relationship in the gases. Temperature volume relationship. As we have learned that to the representation of the properties of the gases, we have three parameters: pressure, temperature and volume. Okay, so here we have to discuss about the relationship between temperature and volume relationship. It means temperature volume is here. It means third one, that is pressure will remain constant. Pressure will remain constant. Okay my dear. Now you may see from here, this relationship is seen easily when an inflated balloon is left in bright sun and it bursts. This is because the air inside the balloon expands with the rise in temperature. Actually, what happens when we will increase the temperature of the gaseous system, then kinetic energy of the gaseous molecules increases. As a result, the molecules of the gases will expand and it will increase the volume of the gas, okay, at the constant pressure. That is why it is written here, in general an increase in the temperature at the constant pressure causes increase in the volume. Means when we will increase the temperature at a constant temperature, then volume of the gas molecule will increase. What is the reason to increase the volume? Because of the increase of the molecular kinetic energy of the gases. Okay, they will show the thermal expansion, and vice versa, that is decrease the temperature at the constant pressure, decrease in the volume. Okay, now suppose you have, this is the container in which movable piston is present. This piston which can move up and down my dear. Gases are present here, gas, and when you will provide the heat to this gaseous system, means by heating, what will happen, this movable piston, it is the piston which can move in up and down side. So when you will increase the temperature, then the kinetic energy of the gas molecule will increase, and the collision of the gaseous molecule on the wall of the container as well as on the piston will also increase. So this piston will allow to move up direction. Okay, now suppose this is the initial state of the piston. So now what will happen, after the expansion, piston will move up to here. Okay, understood my dear? It means expansion take place, means volume is increases. Suppose here volume V1, here volume V2. So what is delta V? Delta V is equal to V2 minus V1 at the constant temperature, constant pressure. With increased temperature, the volume will increase. Okay my dear, so this relationship we have to discuss here with the help of the Charles law. Which law? We have to discuss here with the help of Charles law. Okay, actually Charles in 1787 perform the experiment for the variation of the gases at constant pressure by the variation of the volume and temperature. Volume and temperature, which is said to be the Charles law. Okay, my dear. Now, see, in 1787, Charles studies the temperature-volume relationship of the gases. His work was further extended by the Gay-Lussac in 1802. Experimentally, it is found that with increase the temperature of the gases for 1 degree Celsius, its volume will increase 1 by 273rd part of the volume, total volume, means initial volume of the gases. Means जब हम वॉल्यूम किसी गैस को जब हम हीट करते हैं 1 डिग्री सेल्सियस, तो क्या होता है, उसके वॉल्यूम में 273rd पार्ट का इंक्रीमेंट होता है. Okay, so that is why it is written here, with increase the temperature 1 degree Celsius, the increment in the volume is 1 upon 273 of its total volume. Okay, my dear. Now, on that basis, what is the Charles law? Pressure remaining constant, the volume of the given mass of the dry gases increases or decreases by 1 by 273 of the volume at 0 degree Celsius for each 1 degree increase or decrease in the temperature. Means 0 degree Celsius पर जो उसका वॉल्यूम होगा गैस का, उस वॉल्यूम में 1 by 273 पार्ट का इंक्रीमेंट मिलेगा आपको. Okay, my dear. Now, by the previous concept, we should derive the Charles law. Let's initial volume will be V naught. Initial volume of the gas is, suppose, V naught. Means at which temperature? At 0 degree Celsius. And let's volume V be its volume at temperature T degree Celsius. T degree Celsius means बाई द इंक्रीमेंट ऑफ द टेम्परेचर, कुछ आपने टेम्परेचर को इंक्रीज किया. कितना इंक्रीज किया? यू हैव इंक्रीज, एक मिनट बेटा, वेट नाउ. सी, सपोज योर इनिशियल वॉल्यूम इज V naught and you have increased the temperature 1 degree Celsius. Then how much increment will be there? Total volume V become, at by the increase of the temperature 1 degree Celsius, V naught into 1 upon 273. Okay, suppose you have increased the temperature 2 degree Celsius, then V naught plus V naught into 2 upon 273. But suppose you have increased the temperature T degree Celsius, then what should be the total volume? V naught plus V naught into T upon 273. Okay, so this one written there. By increase the temperature T degree Celsius, the total volume V become V naught plus initial volume divided by 273 into T. Sorry, I forgot to write there V naught. Okay, now, so this is the at constant pressure. Once again I am telling, there it should be V naught into T by 273. So V naught we have to take common from here. So what will happen? 273 plus T upon this. So this 273 plus T, it is the absolute temperature, capital T. So what will happen? V is equal to V naught upon 273 into T. For the given mass of the gas, V naught upon 273 is equal to, what will happen? It will be constant. So if you will put this value in equation number this 2, then what will happen? It become V is equal to, since this is constant, so K into temperature T. It means V is directly proportional to temperature. According to Charles' law, you can tell that at the constant pressure P, the volume V is directly proportional to the absolute temperature, means temperature. With increase the temperature, volume will increase. With decrease the temperature, volume will decrease. So Charles' law may be stated as volume of the given mass of a dry gas is directly proportional to its absolute temperature if the pressure remain constant. Okay, this is the statement for the which law? Charles' law. Now, this is called the Charles' law equation. Which equation called Charles' law? V is directly proportional to the temperature, or V by T is equal to constant. This is known as Charles' law equation. V by T is equal to constant. So according to this equation, if the temperature is double, the volume would be double. If it is, see, this is very important statement, my dear, because in the target examination you are getting it in the form of numericals. If the temperature is double, the volume would be double according to the Charles' law. If it is reduced by half, then volume would also be reduced by half. Very important point for you. Okay. Now, this is the graphical representation of the Charles' law, which is said to be isobar. Iso means same, that is constant. Bar means pressure. Pressure will remain constant. Okay, my dear. You may see this graphical representation. It is in between the volume and the temperature at the given pressure. What happened? At minus 273.15, that is minus 273.15, it means at the when the temperature of the gas will be minus 273 degrees Celsius, then the volume of the gas will be 0. Okay, then the volume of the gas will be 0 by use of this concept, this graphical representation. That is the conclusion. This is the explanation of the Charles' law in the term of the molecular motion, that is kinetic energy. As we have discussed that when we increase the temperature, then what will happen? Then the kinetic energy of the gas molecule will increase. So collision between the collision of the gas particles with the wall of the container as well as the piston will increase. Since piston is movable from top to bottom, means up down up down up down, it can move. So when the particles will collide with the wall of the piston, then what will happen? It will apply the force on the piston. So piston will move up and it will show the expansion, that is thermal expansion in the gaseous system. As a result, volume of the gas molecule increases. Okay, my dear. So thank you. God bless you. Have a nice day.